Hi dear folks, this is the third linear programming model we are about to develop. In that I will be simplify the uh, learning, and I will be telling you how to develop the model through the problem. And this linear programming model you may solve through the graphical method or the other method like simplex and others. Let's so the problem is the crumb and custard. The problem is the crumb and custard bakery makes coffee, cakes, and Danish pastries in large pans. So, coffee, cakes, and Danish pastries in large pans. So, the quantity is in pans, okay, and the two things are being made, Danish pastries and cakes. So, the decision variable would be x would be the pans of coffee cakes, and you see y would be the number of pans of Danish pastries. So you may decide over here up till now, or you may decide afterwards. Both are correct. Data is given, so you may decide right now, or if you want to be sure, so you may decide afterwards. But the decision variable has to be uh, defined clearly. The main ingredients are flour and sugar. There are 25 pounds of flour, so it means the main ingredients are flour and sugar, and there are 25 pounds of flour and 16 pounds of sugar available. So that is the maximum quantity available. That is the maximum quantity available. And the this is our constraint. So you see in every problem, in every linear problem, we have the constraints, and we have to minimize the cost or maximize the profit. So constraint must be there. So the constraints are over here the flour and the sugar. So 16 pounds of sugar is available, and the demand for coffee. There are 25 pounds of flour and 16 pounds of sugar available. So these are the constraints. The demand for coffee cake is 5. So you see the demand for coffee cake is 5. It is a demand constraint, that it is 5, either it is 5 or lesser than that. So demand for coffee cake is 5. Okay. So 5 pounds of flour and 2 pounds of sugar are required to make a pan of coffee cake, and 5 pounds of flour and 4 pounds of sugar required to make a pan of Danish. So you see, uh, it is a mixed recipe is given. So you have to be calculated about it. That flour, 5 pounds of flour. You see, 5 pounds of flour is given for a coffee cake. 5 pounds of flour is given for a Danish pastries. So you see flour constraint would be 5x plus 5y, and the maximum pounds of flour we have is 25. So it will be less than or equals to 25. Sugar constraint is also given, that 16 pounds is maximum sugar is available. Okay, and 2 pounds of sugar are required to make a pan of coffee cake. 2 pounds of sugar over here you see, and 4 pounds of sugar are required for Danish pastries. So sugar constraint is over here, and the maximum is less than or equals to 16. So this is, we are done with the all of the three constraints, and non-negativity constraint must also be there. Without non-negativity constraint, we cannot um, justify the decision variable, because decision variables are telling that the quantity can never be in the negative. It has to be there. There need to be some quantity so that we can minimize the cost or maximize the profit. Okay, move ahead. A pan of coffee cakes has a profit of $1, and a pan of Danish pastries has a profit of $5. So it's a profit, data is given. So we must maximize the profit with this equation 1x plus 5y. Okay, determine the number of pans of cakes and the Danish pastries to produce each day so that profit will be maximized. So X and Y value has to be find out so that we can get to know the uh, value of Z. So graphical method is the recommended one. You may use other method as well. Thank you.